Okay, today we're looking at adding and subtracting algebraic fractions. So in 6.1 we reduced fractions. In 6.2 we multiplied and divide fractions. And in 6.4 we're going to add and subtract. So let's go back to regular fractions. So remember, when you reduce, you're really just factoring and canceling out the common factor. When you multiply, you factor everything, but now you can cross cancel. When you can cancel on a diagonal, or you can cancel up and down. And then when you divide, the first fraction stays the same. You flip the second fraction and change it to multiplication. So first one stays the same, change it to multiplication, flip, factor everything, and then cancel. But today we're looking at adding and subtracting. So when you add and subtract fractions, you can only add things that are alike. So you can only add apples plus apples or oranges plus oranges. And so fractions are kind of the same thing. The denominator has to be the same in order to add them. So I kind of like you to think of this as 2 3s, and you want to add 1 3 would be 4 3s. What you're adding doesn't change. So the common denominator, the bottom number, always stays the same. But what if you're adding denominators that are different? So here I have 2 5s and I want to add 1 1/2 or 1 2. I can't add a 5 and a 2 because they're different. So we have to do what's called a common denominator. And so to get the common denominator, you can look at multiples, which is how we talked about in 0300, because that's much easier for just numeric fractions. But for algebraic fractions, what you want is one of every factor. And so you need, I need a 5 and I need a 2. So 5 times 2 would be 10. So that's our common denominator. Now, if you looked at your multiples, you see your multiples would be 5, 10, 15, 20, 2, 4, 6, 8, 10. The first one they have in common is 10. And so you can also just take one of each factor. Now this becomes a problem with larger numbers, and we'll talk about that in a minute, but it will always work. You just might have to reduce it in the end. Okay, so once you find your common denominator, then you change your fractions by looking at the missing factor. Because to get from 5 to 10, I'm missing a 2. So I'd have to multiply that by 2. So I have to do the same thing to the top. 2 times 2 is 4. And then to get from 2 to 10, I'm missing that factor of 5. So whatever you multiply by the bottom, you have to do the top. 1 times 5 is 5. And then once you have the same denominator, then you can just add the tops. 4 10s plus 5 10s is 9 10s. Just remember, the bottom never changes once you have a common denominator. So let's look at that as far as algebraic goes. So now we're just throwing in letters, but you really are thinking about those exact same rules. So in this first one, I have 5 p's and I want to add 2 p's. Because the denominators are the same, I can just say 5 plus 2 is 17 p's. Remember, the denominator doesn't change. This next one, I have x over x plus y over x plus y. These are the same. And remember, we talked about when you're adding or subtracting two things, they're considered one unit. They're one object. So they have the same denominator. So that denominator is going to stay the same. And then you just say x plus y. You can't really add those, so you just write x plus y. But now we have the exact same thing on the top as we do the bottom, so those would both cancel, leaving us a 1. So if the denominators are the same, you just add the numerators and that denominator stays. You can always reduce if possible. Okay, this next one, we've got p over 8 plus 4 over 5. So for our common denominator, we need an 8 and a 5. And you do not have to show this step, but well, no, I'm not gonna show it, I'm sorry. So we need an 8 and a 5, so we multiply those. 8 times 5 is 40. And that's gonna be our denominator, because we need an 8 and we need a 5. And so then to compare, to get from 8 to 40, I would need to multiply by 5. So I have to do the same thing to the top. So 5 times p is 5p. To get from 5 to 40, I'm missing that factor of 8, so I need to multiply by 8. So I need to do the same thing at the top. 8 times 4 is 32. Now the denominators are the same. And so I'm going to add my numerators. Now I can't add a letter and a number, so you just write it as 5p plus 32. Now it won't go so far in this class. I'm sorry, I'm trying to keep this phone from shaking. In this class, but if you could reduce, you want to reduce, but none of these today will that happen. But it could happen when you get on up into college algebra. Okay, this next one, the denominator has numbers and letters. And so you want one of every factor. And so you really got to think of these as separate things. So this is a 2, this is an x, this is a 7, and this is a 2. So you don't have to write this down. So my common factor, I need a 2, I need a 7, and I need an x. Because they both have one x, all you have to take out is one of them. If they have more than one, then you need to take out the largest amount of x's, because on a common denominator, you need to have what both of them have in common. So if I have 2 x's and you have 1 x, what we have in common would be we both have that. We would both need 2 x's to have the same thing. So 2 times 7 is 14. So our denominator here becomes 14x. Again, one of every factor. I probably shouldn't have written that there because it's kind of in the way. And then you compare. So we already have an x here, but to get from 2 to 14, I would need to multiply by 7. So I do the same thing to the top. 7 times 3 is 21. From 7x to 14x, I would need to multiply by 2. So I do the same thing to the top. 3 times 2 is 6. Then the denominator stays the same, and you just add the numerators. 21 plus 6 is 27. And that's your answer. Again, I'm sorry for the camera. I've tried everything to fix the shaking camera, and it just, nothing works. Okay, let's look at this next one. So now we just have one number, 5, but we have an M2 and an M1. And so you've got to take, our common denominator is going to be the 5 and then the M2. When we're factoring out a common denominator, we always want the smallest exponent. It's really bad today, the shaking. But when we're, trying to hold it with my hand, when we're doing a common denominator, you need the largest exponent. So if you have a 2 and a 1, you want to pick the 2. And you'll see why, because when we go to, if you picked a 1 here, then you would have too much here, and you couldn't do a comparison. So to get from 5m squared to 5m squared, nothing changed. So I'm going to bring down the 12. Then from m to 5m squared, you're comparing what you're missing. So do you see up here, I'm missing a 5 and I'm missing an m, because that's what I would need to make that 5m squared. So I need to multiply the same thing to the top. So I'm going to say 5 times 5m is 25m. Then you bring down the common denominator. I think I finally figured out how to keep it from rattling. I'm holding it with my left hand and it's not shaking as good, so that's good. So we've got the common denominator down, and then we're going to say 12 minus 25m. I can't really combine that, so I just write 12 minus 25m. And that's your answer. Now, if you could factor and cancel, you could do that, but you won't need to do that on any of these in this class. It might happen in college algebra that you have to, but not in here. Okay, let's look at this last one. So this one I have an m, but this one is an m plus 1. So you got to think of this as one unit. Remember, anything added or subtracted is one thing. And so you've got to think of them as two different things. When it's m and m squared, they're not added or subtracted. They're their own single little unit there. So you count them individually. But because this is an m plus 1, that's thought of as one unit or one whole factor. So for this one, I need a single m, and I need a married m. I know that's silly, but when I used to teach high school, that's what I would say. The second, this guy's married, so he can't go anywhere without his partner. Okay, so we're going to have an m and an m plus 1 on the bottom. And then we're going to compare. To get from here to here, do you see we're missing the m? So I have to multiply the top by that m. So the top becomes a 3m. To get from here to here, I'm missing that m plus 1. So I need to multiply the top by m plus 1. And you can do this in one step, but I'm going to go ahead and show an extra step here. So this 4 times m plus 1 comes down. Now what makes this a little bit of a problem is that now we need to distribute here. But just be careful because this is a negative 4. So you've got to distribute a negative 4. So again, you don't have to show this extra step. You could kind of do this in your head, but I'm going to show ahead and show it. Is that this becomes a negative 4m minus 4 when you distribute. Because see, negative 4 times m is negative 4m. Negative 4 times positive 1 is negative 4. And that's all over m times m plus 1. And now our common denominator comes down. And we combine like terms on the top. So do you see here we have 3m minus 4m is a negative 1m. And that minus 4 just comes down. And that's your answer. So just be careful. This one's on the test, or I know it's on the quiz. But just be careful when this is a negative, it changes that second sign. Remember, anytime you distribute a negative, it changes that second sign. The biggest mistake made on this one is making this a positive 4 here. But this negative makes it a negative 4. So that's adding and subtracting algebraic fractions. So you're ready for the 6.4 practice problems.